Well, hello, welcome to this vlog. Today's vlog, we're going to talk about multiplying polynomials. What does that even mean? Polynomials means one or more terms. Polynomials. Multiplying means we're going to multiply them together, and we'll see what happens. There are several types of multiplying polynomials. We have one term and one term, or one term with two terms. You can multiply two terms with two or three terms. There are many possibilities. Today we're going to start with multiplying one term with another term. We have our examples right here in front of us. The one has one variable, m cubed times m to the fourth. When we multiply these, they have the same base, so we use the exponent rule, and we would add the exponents, the product rule for exponents, as covered in previous vlogs. If you don't know these rules, go back and watch that vlog, please. Okay. As we've said, this is going to happen for each base with an exponent. You'll multiply the bases. If you're multiplying numbers, you can do that like multiplying numbers. But if you have the same base, meaning the variables are the same, m and m, n and n, z and z, when you multiply them with exponents, you use the product rule for exponents, like now. We're going to multiply 5 times 2, and it's 10. We'll hold this right there. Next, we're going to look for, we have a first variable is m. We have to look for an m in the other term, and we see that here. So now, we have m squared times m to the m cubed is m to the fifth. Now let's look for our n variables. We have n times n cubed becomes n to the fourth. P cubed times p squared equals p to the fifth. Now we have q. Okay. Sometimes students freak out when this happens. I have q over here, but q isn't over here. What do I do? I only have one q. We're going to keep the q. We're not going to lose it. It's going to be in the answer. Okay? Now you can see on the side here 10, m to the fifth, n to the fourth, p to the fifth, and then q. We're going to clean it up now. Really, it's like we have, I think, 5 different multiplication problems and work on them individually, and then in the end, you bring them all together. We'll see in our next example. So we have 2 examples here. 2 monomials being multiplied together, both one term and one term. What we're going to do is find the matching bases and multiply them and work on that problem that way, step by step. It's kind of small. I'm going to make these examples bigger so you can see them better. It's a little fuzzy, but sorry about that, but it's much easier to see this as it's bigger. The example A, we have 12 times 1/3. We can multiply numbers together. Then we have x to the fourth times x. We can multiply that together. So we'll go through each variable by itself. Okay, now as we see this, we have y to the first and y to the negative 3. It's okay for right now. Don't worry about it yet. Now we've gathered our variables and numbers together by like basis, and now we're going to go and multiply them together. I didn't like the arrow it was pointing. It was pointing to the z variable. It was the wrong place. Anyways, our answer is 4x to the fifth, y to the negative 2, and z to the negative 4. And we're not done yet, though. We have our negative exponents, and we can't have it in our final answer. We have to change them over to positive exponents. And that's our final answer for the first example. Now we'll go to the second example, B. It's the same process as before. So now we can see we got a whole lot of b's in the first term, but not in the second term. That's okay. We're still going to leave b in our answer, b to the fifth power. Now I'm ready to actually go through and combine these now. You can see that I've used a to the first power. I've written down the first power and d to the first power. I don't have to write the first power down, but I'm just making it clear so you know what's going on. Like d to the first power times d to the negative 1 power. I know what's going to happen. But remember, when we multiply like bases, our exponents are added. We'll clean it up now. Okay, this answer is not quite finished yet. Well, first thing, our fraction isn't fully reduced. Okay, 3 can divide 3, 3 can divide 24. We can simplify it. as well as our last variable, d to the 0, is really 1. We don't normally write that, but for these purposes, I was doing it to demonstrate what was going on. Oh, I'm sorry. Let me fix that. And that's our final answer. Thanks for watching this vlog, and I'll see you next vlog.